Hello students, introducing myself, I am Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. Today my first lecture topic is Introduction to Control System, followed by the code EE503. The control system has become an integral part of modern society. It plays a vital role in our day-to-day life. Without being familiar with the terminology the automatic control, the peoples in the past have utilized the concept of automatic control. Besides its importance in state space or missile guidance, aircraft positioning, the control system has become an integral part of our daily life, starting from the bread toaster, room temperature control, traffic control, automobile steering control, as well as economic regulation systems. The control system is not limited to any particular discipline, but equally it is applicable to the chemical engineering, electrical, instrumentation, mechanical, civil engineering, and so on. Now, the launching of satellite tracking the enemy on radar or the regulating power plant are some examples of the man-made control system. It is based on the principles of feedback theory, the linear analysis, circuit theory, Laplace transform, matrix algebra, and calculus. And it is also exists in the nature. Within the human body, there are examples, many examples of the control systems. Now, at the present time, we are actually at the computer age and in the era of the modern control engineering, whose roots can be traced back into 16th century. The objective of the course is to use the modern control theory to analyze and design feedback control systems. And there have been many developments in control systems during the recent years. In the past days, the Industrial Revolution in Europe was marked by the invention of advanced gun mills, boilers, and steam engines. And those devices could not be adequately regulated by the human. Hence, the control system originates and variety of control devices such as the flow regulators, temperature regulators, the pressure regulators, or the steam engine with the rotary output motions were invented. In the mid of the 18th century, the mathematics was used to analyze the stability of the feedback control systems. Since the mathematics became the formal language of the control system, the differential equations were used in analyzing motion of the dynamic systems by Lagrange and the Hamilton. And the Maxwell analyzed the stability of Schwarzschild governor by linearizing the differential equation of motion to find the characteristic equation of the system. Later on, at the end of the 18th century, the stability of the nonlinear system using the generalized motion of energy was introduced by Lyapunov. And gradually, the classical period of control system starts after the Second World War. In this age, the time domain analysis, the frequency domain analysis has been introduced and used to linearize the nonlinear system and examine its behavior. As it is not possible to design the control system for advanced nonlinear multivariable system, then with the help of Euler and the Kalman, a new era in the control system had begun. And that is the era of the modern control, such as the nonlinear control system and digital control system. In this control system 1, that is EE503, we will learn the classical approach of the control system. So now, what is the course outcome? At the end of this course, the students will be able to design the control system or define the transfer function using the signal flow graph or block diagram, and can perform the time domain analysis or the frequency domain analysis, and can be able to design the different computation techniques using the different controllers. So these are the course outcomes of the control system 1. And this is the lesson plan for the module 1. And for module 1, I will give the 2 lectures, and lecture 1 will contain the basic concept, examples of the control system and concept of transfer function. And lecture 2 will cover the classification of control system. So what is the control system? So it is a combination of 2 words, that is control and system. And the control means to regulate, direct or command a system so that a desired objective can be obtained. And the system is that an arrangement of combination of different physical components that are connected or related together to form an entire unit to achieve a certain objective. That means it operates on input, and according to that input, it produces an output. Addition of these gives a control system. So the control system definition is like this: the arrangement of the physical components connected or related in such a manner to command, direct or regulate itself and another system to obtain a certain objective. Now a system has some inputs, and according to that input, the system will produce the output. Generally, in time domain, it is represented by RT, and the output is represented by CT. We can use XT as an input and YT as an output also. Now, the input variables, inputs are different type of signals. That means the electrical signal, mechanical, pneumatic, hydraulic, and the biomedical signals, or the different physical variables like the temperature, pressure, liquid level, or the electric voltage, all of these can be used as the input of the system. And as for the input of the system will produce the output. Throughout this course, we are going to study the single input, single output system. That means only one input will be present, and according to that input, only one output will be produced. And multivariable systems are also possible. That was the MIMO system. That means there are multiple number of inputs and multiple number of outputs. But we will consider the CISO only. Now, in that system, there was no feedback. As there was no feedback, so that type of systems are known as the open loop system. And then there is a closed loop system when we use the feedback in the control system. Here, in this feedback control system, the RT is the reference input, and the reference input is directly goes to the controller through the error detector, or this is actually a summing point, and output of the summing point is the algebraic sum or the difference of the different inputs coming to the summing point. So through this error detector, it goes to the controller, and the controller output will be produced, and it goes directly to the plant of the system. And if there are some disturbances, then the disturbances are added to the plant of the system, and next we get the output from the plant. Now, this portion of output of this CT is used as the feedback, and it goes to the error controller, and this error becomes the algebraic sum or difference between this R, that is the reference input, and this feedback. So this is the complete feedback control system. Next, consider an example. So I am considering here the liquid level system. Now, control system is actually an interconnection of different components which gives the desired response. And the objective of any control system is to maintain the output of a system at a desired value. So, suppose the desired level of the liquid height is 5 feet. That means it should be used as the reference input. And the control system refers to several elements or the components such as sensors and the final control element. And here the sensor is the level transmitter and the actuator or the final control element is the valve. The actuator is the device which is used to infrared control or outflow rate control, and the sensor is basically a transducer which is used to transform one type of physical quantity to another type of physical quantity, generally the electrical one. And different type of sensors can be used. Those are the tachometers, accelerometers, LVDT, that is linear variable differential transformer, the thermocouples, strain gauge, etc. Generally, these sensors are used to measure the control variable of the system. Now, the system has input variables which can be manipulated to modify the control variable, and those variables are known as the manipulated variable. Now, in this liquid level system, the level transmitter is the sensor and the valve acts as the final control element, and the liquid level of the tank can be controlled by controlling the inflow rate through the in the valve opening. The control system compares the desired level, that is the reference input, that means the 5 feet height of the liquid level, with the current level, that is the control variable, that is measured by the level sensor. Suppose at the beginning the level transmitter is measuring the liquid level is 3 feet height, so it is control variable is 3 here and reference is 5, and when reference input is given to the controller, and when reference input is 5 and this level transmitter is measuring 3, then difference of 5 minus 3, that is 2, is given to the valve to this controller, and according to that the valve will keep open to increase the level of the liquid. And if any difference or difference may be positive or negative between the reference input and the control variable, then the controller takes the necessary action to either increase or to decrease the valve opening as per the cases. So, this is an example of liquid level system. The next is the transfer function model. Now, the transfer function is used in the Laplace domain. So, in time domain, we have used the input RT, and RT is given as the system, and according to the input RT, the system output, that becomes the CT. Now, in Laplace domain, we can convert all these equations into Laplace domain. So, the RT becomes RS and CT becomes CS. And in this frequency domain, if we find out the ratio CS by RS, assuming that all the initial conditions are 0, then the system will be represented by the transfer function. Or we can say that the transfer function is defined as the ratio of the Laplace transform of the output by the Laplace transform of the input. So, this is the transfer function. So, in this lecture, we are familiar with the control system and the basic components of control system, the block diagram of control system, and the basic of the transfer function model. Hope after this lecture you have a clear idea about today's topic. Now, we'll go through some question answer session in the context of this lecture. Now, you are requested to go through gradually and try to solve the multiple choice type questions by your own. The answers are also attached at the end of each question.